Hello and welcome to my YouTube channel. So today we are going to discuss about concrete mix design according to BRE, the unrestricted design. And we're going to look through what concrete design means and all the steps that are required so as to design your mix. So first, we need to understand what mix design is. So we need to know that we are designing concrete so as to find the basic proportions of materials that are going to be used up in the concrete. We need to specify the amount of coarse aggregate, fine aggregate, the cement and the water content that will be in concrete. And this concrete design, it affects certain properties which include workability, the compressive strength, and the durability. So we have to design putting these properties under consideration so as to come out with concrete of a specific type of property. And that's why we do the concrete mix design. And so we have steps that are used in calculating this concrete mix design. Our first stage will be dealing with finding out our characteristic strength that will lead us to finding our water cement ratio. Then we'll come and find the workability that we require for the concrete, and this will lead us to finding our free water content. And thirdly, we'll come and find the cement content for the mix design according to our free water content and our free water cement ratio. Then at stage 4, we'll come and find the total aggregate content. Because we have the cement content, we have the water content, we can find the aggregate content. And finally, we'll come and find the fine aggregate and coarse aggregate contents from the total aggregate content. So these are the basic steps that we are going to deal with in this mix design. And then finally, after conducting all these stages, we'll come and do the proportion of materials that are required in the mix design that we've just designed. So step 1 starts by specifying our characteristic strength. This is the class of concrete that you want to design for. For us, we're going to design for class 25 of concrete. You can design for class 20, class 30, class 35, class 40. Then we are going to state our date of full strength, which will be on date 28. Then we are going to find the proportion defectives. These are statistical values, the proportion defective and the standard deviation. And for the proportion defectives, we are given constants. For 5%, here they are. We are given a K value for 10% defectives, 5% defectives, for 2% and for 1%. So you have to select the amount of defectives in accordance to the work that you're going to carry out. Like for us, we are going to carry out a general use, so we are going to select a 5% defectives. It may depend with the work that you're going to carry out, will depend on the amount of defectives you're going to select. Then we have to find the standard deviation. This standard deviation, we get it from figure 3. And figure 3, we have standard deviation against characteristic strength. So we have this graph, 2 lines. The first line indicates that if you are doing the experiment, but the values that are previously done for this experiment are less than 20 results, then you'll have to select 8. While if there are more than 20 results, you'll have to select 4 for your standard deviation value S. So you select the appropriate standard deviation according to your mix design, what you are going to design for, the amount of results that you're going to get, and the amount of results that you have. You select the correct value of S. Then we come and find margin. Sorry for the typing error here. We come and find margin, which margin is the product of standard deviation and K. K is the constant from proportion defectives. We find it's 8 times 1.64. K for 5% defectives, which gives us 13.12. Then finding the target mean strength, we come and take the specified characteristic strength, which was 25, and our margin. So our strength, our target will be between up to 38.12, putting margin of error into the equation. But we are going to design for class 25 concrete. So after finding the target mean strength, we then come down and check on the cement class. We have our the cement class that we're going to use in the project that we're going to do. That's why we're designing it. We are going to use class 42.5 cement OPC. And then our aggregate type is going to be crushed. You can either select a crushed aggregate type or an uncrushed aggregate type. But for us, the aggregate that we have is crushed. Then you go to table 2, and here is table 2 here. Table 2. All these tables are in the BRE. I'm going to leave it in the description for the video. You can download it. So the table 2 will give you a cement class 42.5, 52.5. There can be more. And the type of course aggregate, which either can be crushed or uncrushed, and the compressive strength days. For us, we are going for day 28, crushed, and class 42.5, which will give us a 49 newtons per millimeter squared. So that will be our strength at a free water cement ratio of 0.5 from according to the table. So now we go find out the free water cement ratio with the value that we have of 49 and 0.5 and 38. We go to find our free water cement ratio, and this we go to figure 4, and here is figure 4. All these figures are in the BRE. You'll find them in the description. So for figure 4, to determine the free water cement ratio that we are going to use in our mix design, our first value was 49 compressive strength against free water cement ratio. So we go to 49, and 49 is basically somewhere here. Then we draw a curve relative to this curve up to our datum point, which is 0.5. Then we come to 38. We draw a curve relative to the other curves up to the datum point. Then we find out the difference between this point and the top point for 49. Then after doing that, you come and project the difference on this scale from 0.5. You project it going on the different direction, and you will then select your free water cement ratio. For us, our free water cement ratio was 0.61 from this figure 4. There is a formula for calculating the free water cement ratio rather than getting it from figure 4. I will leave it in the description. I didn't put it in this PowerPoint. Then our maximum water cement ratio that was specified is 0.6. So we cannot exceed 0.6. So we have to pull this down from 0.61 to 0.6. So we select our water cement ratio of 0.6. Then we move down to step 2. We finished step 1. We found our water cement ratio, which is 0.6. Then now we move to step 2. For step 2, you have to specify the slump value that you are requiring for your project. So for us, the slump value was specified at 45 millimeters. Then you specify the maximum aggregate size, which for us is 20 millimeters, and the free water content, you find it from this figure 3. So you come to the specified maximum aggregate size, which is 20. Then you come to type of aggregate, crushed. Then you come to our slump, which is between 30 and 60. So our free water content is 210 kilograms per meter cubed. You check on the maximum aggregate size, the type of aggregate, and the desired slump. If you are using Weber time, you can select the amount of time that you require. But for us, we're using the slump. So we've now found the water cement ratio, which was 0.6, and our free water content, which is 210 kilograms per meter cubed. So we go to step 3, which is finding the cement content. And our cement content is equals to free water content, which was 210, over water cement ratio, which was 0.6. And we find out that our cement content is 350 kilograms per meter cubed. Now we have our free water content and our cement content, which is 350. So we move to step 4, and here we have to specify the relative density of aggregates. If you are not given or you have not calculated it from the lab, you can assume a value of 2.7 for crushed aggregates and 2.6 for uncrushed aggregates. So we go to figure 5 and find out our concrete density. So here is figure 5. It's also in the BRE, you'll find it. So you come to 2.7, then you come to your free water content, which was 210. When you project up and 2.7, you find out that they will meet at exactly 2400 kilograms per meter cubed. So our concrete density is 2400 kilograms per meter cube according to figure 5, as I've shown you below. 210 free water content and the specific gravity of the aggregates. We find our concrete density. Then now we have the density of concrete, we have the value of cement content, and we have the value of water content. So finding the total aggregate content, you take the concrete density, you subtract the water content, and subtract the cement content so as to find the aggregate content. So it will be 2400 subtract 350 plus 10, which is the cement content plus water content. You find that our aggregate content is going to be 1840 kilograms per meter cubed. This is composed of fine aggregate and coarse aggregate combined together. So this will now take us to our step 5. And step 5, now we have to, it is based on lab results. So first, you get the percentage passing the 600 millimeter sieve. For us, from our sieve analysis for fine aggregate was 65%. And then you find the fine aggregate content. This is by taking the total aggregate content times the proportion of fine aggregates. And the proportions of fine aggregates, you get it from figure 6. I forgot to put my figure 6 on the slide, but it is there on the BRE. You'll find that the proportions of fine aggregate will be 0.33%, 33%. You take the concrete density, multiply by the proportions of fine aggregate from figure 6, and you'll find that the fine aggregate content is 607.2 kilograms per meter cubed. Then while you have the fine aggregate content, we can basically find the coarse aggregate content, which will be total aggregate content minus the fine aggregate content, which will be 1840 minus 607.2. And you'll find out that the coarse aggregate content is 12.32, 1232.8 kilograms per meter cube. So we found out that we have found all the values. We have our water content as 210, our cement content as 350, our fine aggregate content as 607.2, and our coarse aggregate content as 1232.8 kilograms. So we have finally designed our mix, and these are the values that you are going to use for any particular amount of volume. Like for me, I was doing a project and I was going to have 36 cubes which were 100 by 100, and so it gave me a volume of 0.036 meter cube. So I was able to find the amount of materials that I was going to require for the complete project, and you will basically take the volume times the material. So when you take 0.036 times 210, you get 7.56. The same to cement content, to fine aggregate content, and to coarse aggregate content. And that is basically how you do concrete mix design. It's a simple process. You just have to follow all the steps procedure from the top to the bottom, and everything will flow, and you'll finally arrive at your materials. And these are basically the proportions that you are required to state so that they can be used for preparing the concrete of the properties that you've specified above. So after getting these materials, you have to go and conduct an experiment so as to find out the if the properties are really as you calculated them for. So you prepare your cubes, you crush them, you measure your slump value and all that. So I'm going to leave the link to download the BRE that I'm using, and also please, if the video was helpful, please like this video and subscribe to my channel. I'm going to be posting more videos on civil engineering topic and discussions. So thank you for watching my video. Have a good day.